Number theory. We've said this section was number theory, but we haven't really talked about what number theory is. Number theory is simply the study of numbers. And to study the numbers, let's look at some different types of numbers. We've already discussed the natural numbers, the ones we use to count. N equals 1, 2, 3, 4, 5, etc. The next set of numbers are the whole numbers, and they include the natural numbers, and they also include the number 0. So we're just going to take 0 and add it to the 1, 2, 3, 4, etc., etc. Notice that all of these natural numbers are part of the whole numbers. Our next group of numbers are the integers. We use a Z, comes from the German word for numbers. These are the whole numbers plus all of their negatives. So we have the 0, 1, 2, 3, 4, 5, but we also have -1, -2, -3, and so on. And again, we'll notice that all the whole numbers are inside of this group called integers. Our next group of numbers are the rational numbers. They're numbers of the form P over Q. We give them the symbol Q, the fancy Q, for quotient. And in these numbers, the P is an integer, and we call the top integer the numerator. Q is also an integer. It's an integer not equal to 0, and that's called the denominator. Now, one thing to note, as so far all of the groups have included all the numbers before them. So integers include all of the whole numbers, and that includes all the natural numbers. The integers are also included in the rational numbers because we can write integers such as 4 as 4 over 1. And so these are included in the rational numbers. They don't have to look like a fraction. They just have to be able to be written like a fraction. 4 could also be written 8 over 2. So it's a rational number. We say that a rational number is reduced if the greatest common divisor of the numerator and the denominator is 1. For example, 35 over 49 is not reduced because 35 and 49 are both divisible by 7. We want the greatest common divisor to be a 1. The way we deal with that is by dividing out common factors. And one way to do that is to factor the numerator and factor the denominator. And then we can divide the top by 7, leaving a 1 there where that 7 was. Divide the bottom by a 7, leaving a 1 where that 7 was. And 5 times 1 is 5. 7 times 1 is 7. So we say that 5/7 is the reduced form of 35 over 49. Again, this process is easier if you use prime factorization. You don't have to. In this case, 105 over 150. We could factor each of these, divide 3 out of the top and bottom, divide the top by a 5, divide out one of the 5's in the bottom, and that leaves us with 7 over 10. A mixed number is a number with an integer part and a fractional part, like 2 3/5. An improper fraction is one where the numerator is greater than the denominator, like 13/5. In fact, 2 3/5 and 13/5 are the same, they represent the same quantity. Sometimes we need to convert back and forth between these. To convert from a mixed number to an improper fraction, We're going to multiply the whole number by the denominator and then add that to the numerator. For example, with 3 and 2 11ths, we're going to multiply the 3 times the 11 to get 33, and then we're going to add the 33 to the numerator. And so we get 33 plus 2 is 35 11ths. And we're done. We have converted the mixed number to an improper fraction. Now, one thing to note is if the mixed number is negative, don't include the negative in the multiplication. Just let it go along for the ride. So I'm not going to say negative 4 times 4 is negative 16 and then add that to 3. That would just mess me up. What I will do is just let the negative go along for the ride, and then I'll do 4 times 4 is 16, and then we'll add the 3 that was already in the numerator, let the 4 go along for the ride, and that goes negative 19 fourths. Alright, going the other way, to convert from an improper fraction to a mixed number, we're just going to divide the numerator by the denominator. We'll use long division. The quotient of this long division will be the whole part, the integer, and the remainder will be the new numerator. So for example, 46 over 7, we're going to have 7 go into 46. Well, let's see, 7 will go into 46 6 times. 6 times 7 is 42. When we subtract, we get a 4, and that'll be our remainder. So this is going to be 6 with a remainder of 4, or 6 and 4 sevenths. To convert negative 192 over 13, again, we're just going to let the negative go along for the ride. Negative 192 over 13. 13 goes into 192. Let's see, it'll go into 19 once. 1 times 19 is 13, minus 3 is 6. Bring down the 2. 13 goes into 62 4 times. 4 times 13 is a deck of cards. And 62 minus 52 is 10. So our whole number is going to be 14. Again, the negative goes along for the ride. And our remainder is 10, so that becomes the numerator. So we get negative 14 and 10 thirteenths. Fractions and decimals. All fractions can be represented as decimals. So all rational numbers can be written as a decimal. We'll see in a little bit that does not go both ways. So, some rational numbers or some fractions will produce a terminating decimal. For example, 1/25 is the same as 0.04. Other rational numbers will produce a repeating decimal. For example, 5/9 is 0.555555, and it keeps going forever. You'll notice the digit 5 is what's being repeated, so in order to represent that, we do 0.5 and we put this bar over the top. So it's 0.5 repeating. To convert from a fraction to a decimal equivalent, we're going to divide using long division. We'll add in decimals and zeros until the remainder is 0, or until the decimal in the quotient repeats. So let's convert 7/20 to a decimal. So we're going to divide 7 by 20. Well, 20 doesn't go into 7, so let's put a 0 there. I'm going to add a decimal, and we'll put in a 0 here. 20 will go into 70 3 times. 3 times 20 is 60. Subtract, we get 10. We'll add another 0, bring it down. 20 goes into 100 5 times. 5 times 20 is 100. Subtract, and we're down to a remainder of 0. So that tells us that 7/20 is equivalent to 0.35. Okay, convert 4/11 to a decimal form. Let's see, we're taking 4 and dividing it by 11. Well, 11 won't go into 4, so I'll put a 0 here. Then we'll add a decimal and a 0. 11 will go into 40, so 3 times. 3 times 11 is 33. And we subtract to get a 7. We need another 0. Bring that down. 0. 11 goes into 70 6 times. 6 times 11 is 66. Subtract, we get 4. Add another 0. Drop it down. 11 goes into 40. Oh, I think I've been here before. 3 times. 3 times 11 is 33. We'll subtract. We get a 7. Oh, I know I've had that remainder before. 0. 0. 11 goes into 70 6 times. 6 times 11 is 66. Remainder of 4. Yeah, I've already had that remainder before. And we see the pattern here. This is going to go 3 6 3 6 3 6. So to write this as a repeating decimal, we will say it is 0 point, and the 36 is what is repeating. So we'll put a bar over both digits.